Hello and welcome to the second video in the series of Python Decorators. In the first video, we have covered everything that was required to get started with Python Decorators. All the prerequisites were covered in that video. If you haven't watched it, I would highly recommend to go and watch it so that you're all set for learning Python Decorators. And this is going to be the first video where we are going to learn about Python Decorators and start building foundations. So what are Python Decorators and why do we need it? So let me tell you a very I'll start by telling a definition of what Python decorators do. So Python decorators actually replace your function with another function. I hope that's really simple to understand. Python decorators replace your function with another function, and but that function, the new function that is going to replace your function, should be accepting the same number of arguments and should return the same result as your function is going to return. So it's really important to understand Python decorators replace your function with another function that accepts the same number of arguments and also returns the same result as your original function. Also, Python decorators are function in themselves. However, if you didn't understand this part, that's okay. But I hope I was able to make you understand that Python decorators, they replace your function with another function that that accepts the same number of arguments and also returns the same result. Okay, the next question is that why do we want Python decorator to do that? Why do we want to replace our function with another function? Rather than explaining this in another definition, let me try to explain it with examples. So let's say if you have a function that computes the nth number in a Fibonacci series, and if you wanted that you also wanted to compute the running time of your function. For example, if you computed fifth number in the Fibonacci series, you wanted the running time that your function took to compute that fifth number in the Fibonacci series. For example, if you wanted to compute 500th number in the Fibonacci series, you also wanted the total running time that it took to compute the 500th number in the Fibonacci series, Fibonacci sequence, whatever you can call it. So if you want to do, but at the same time, however, okay, let me tell you how you can achieve this. You can achieve this in multiple ways. Wherever you can, first thing that you can do is that whenever you call your function which computes the nth number in the Fibonacci sequence, before invoking that function, you can compute the start time, or basically the time where just before starting the execution of your function. And once your function has executed, you can find the end time, and you can compute the difference between end time and the start time, and that's where you will know how much time was taken by your function. I hope I'm making sense here. And another thing that you can do is you can, in your function itself, in the beginning of your function, you can compute the time before your function begins, and at the end of your function, before returning the result, you can compute the end, the 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 end time, and then find the difference between a start and end time. These are okay to do, but you will actually have to modify your function. If you don't want to modify your function and you go by the first method that I told, you have, whenever you invoke your function, you have to compute the start time, end time, and then you will have to find the difference. And let's say if you have a couple of other functions, then you will have to do same thing repetitively. Either you have to modify all the functions, or you will have to, before invoking, you'll have to compute the start time, and after function completes, you'll have to compute the end time and then find the difference. Okay, but there is a third way, and which is more elegant, and I would like to explain that. So if you're looking at the screen, this is that function. This is a Fibonacci sequence. This function computes the nth number in the Fibonacci sequence. So what it does, I've included the signature. So it takes an integer and it returns an integer, which means it will take which position you want that particular number, which, for example, if you want to compute fifth number, n will be 5, and it is going to index from 0. So basically, for simplicity, I've kept it like that. So if you send 0th, you can also send, which means the function also accept 0 as a valid argument. So let's say if you wanted to compute fifth number in the Fibonacci sequence, n will be fifth. And in the return, it will give you fifth number that falls in the Fibonacci sequence. So let's see what is fifth number. Actually, if you start with 0, this is sample small Fibonacci sequence that I've written. It goes after this, but 0th, first, second, third, fourth, fifth. Actually, fifth number is the 5 itself, and sixth number would be 8. So let's say if I want to compute the fifth number and I want to invoke this nth Fibonacci number with n, then I can do, I can execute this example 1. This is the file, and okay, it's taking time. I'll tell you why. So it computed the fifth number in the Fibonacci sequence, and it's 5. I'll tell you why it took time, because I have also introduced a sleep here. So what this sleep does is, so this is first of all, just to recognize, this is an iterative solution, which means it forms on the basis of dynamic programming. If you don't know, it, then it's okay. But it's an iterative solution and works faster, or basically quicker than your recursive solution. So you may not find difference between when you compute fifth number or you find 15th number. Most of the times the difference is so small that it will be hard to recognize. So that's the reason I have introduced this time, which means if you try to compute fifth number in the Fibonacci sequence, the result that you'll get will be in approximately 5 seconds. And if you want to compute 10th, the result that you're going to get will be in approximately 10 seconds. So that is the reason I've included that, so that the delay is evident as we go forward and generate the output for more number of inputs. So that was fine. It took around 5 seconds and it gave me the result as 5. Let me show. However, it will take another 3 seconds to compute this, but it should fairly give me the answer. So it says that, okay, third number is 2. It says third number ignore this th. I should have computed the suffix properly, but number in the Fibonacci sequence is 2. So 0, 1, 2, 3. So this is the third number. Okay. Till now we haven't seen, decorators have not come into the picture, but they will. Now for this function, you want to compute the running time as well. So let me see this. So there is another function that I've written here. Now, before I continue, if you haven't watched my previous video, which covers closures, I would highly recommend going that and watching that video, because it's really important to understand that. And whatever I'm going to explain next heavily relies on the fact that you know what are closures. If you already know it, it's fine. But if you don't know, I would highly recommend go and watch the previous video, which is called as variable scoping and closures in Python. So I have defined this function. This is a function which actually contains another function. So let me break it down for you. I'll call this as outer function, and I will call this as inner function. So there is this outer function, and just try to visualize the structure of the outer function. Don't go inside the inner function yet. Let's try to understand what is the structure of the outer function, compute time. It contains an inner function called as runner, or a nested function called as runner, and returns that function. That's all it does. Outer function, it defines a function called as runner and returns that function. In addition to that, it also accepts a callable. I've introduced this type hint for us to understand, okay, whatever the parameter that we are going to pass in compute time will be a callable. For now, for simplicity, let's say we are going to pass a function, and function is a callable in Python, which means you can invoke that particular parameter. So func is a function essentially. It can be a class as well because class is also a callable, but for this example's sake, let's understand that it's going to be a function and it will be a callable. Okay, I think now you understood, you visualized how does the outer function looks. Now uh, let's try to move with and understand what is this runner function. If you see this runner function, it accepts an integer and returns an integer. And what it does is that it computes the start time. It runs this function, which was passed as a callable in the parent scope, in the local scope of the outer function. So if you, again, I'm saying, if you don't know about closures, it will be hard to understand it. So it is calling this function, capturing the result, which which will be stored in this result variable, and then it computes the end time. Actually, it computes the difference, total execution time. This is going to be your end time. I'm not storing it as separately in a variable, but I hope you understand. This will be end time minus start time, which will be the total execution time. And I have this statement just to print that execution time, and I return the result, which was captured from this function. Now, what are we going to do is this. Before we actually invoke our Fibonacci number, like the way we were doing it and we were computing, what we are going to do is we are going to take the nth Fibonacci number and call this compute time method, compute time function essentially, and pass our nth Fibonacci number function to it. Okay, so let's see what it does. Its compute time, as we saw, is going to take a callable. Compute time is going to take a callable, and it's going to return the inner function, runner, which means when you pass this nth Fibonacci number, which is actually a callable, then compute time, once evaluated, will return the inner function, runner. And that runner is going to be assigned to nth Fibonacci variable again, which means after the execution of this statement, your nth Fibonacci function, or this variable that you used to invoke your original function, which is this function, will now be holding a reference to this inner function, this runner function. What does that mean? That means if you invoke from now on, from here down, if you invoke your nth Fibonacci number, it's going to execute your runner function. I hope I'm making sense. If I didn't, you will definitely get that. Just bear with me on this one. So if you executed this line, your compute time is going to return a runner, which is inner function in the compute time function, and it's going to assign it to nth Fibonacci, which means what this call is going to return? This call is going to return the inner function, which is also called runner. And runner will be assigned to nth Fibonacci number, nth Fibonacci variable. So if you call this function, which means essentially you are invoking the runner function here by invoking nth Fibonacci. I hope I made sense till now, till here. If you didn't understand, I would recommend just go ahead like a couple of minutes behind and then watch it again. Now, what we are doing, we are actually executing this runner function. Now, runner function as we have already seen, it computes the start time and it computes the total execution time of what? Of this function. This function comes from where? It comes from the local scope of the outer function. What does this mean? This runner function is actually a closure which is having an extended scope where it can also access local variables from the outer scope. Even if it is returned from here, it will have access to this func variable which was local to the compute time. And what does this func contains? If you just see it here, we have passed the nth Fibonacci, our original function, which means this func is going to contain reference to our func, sorry, func is going to contain to not our nth, I think nth, which means if we execute func, we are actually executing nth Fibonacci function. Okay, so and when you run the nth Fibonacci here after this line, you are actually executing runner, and runner will in turn run your nth Fibonacci function, which was your original function. Now I hope you understood. Whenever you call the nth Fibonacci function, you are going to execute a runner, which is going to execute your actual original function, and it is going to compute the total computation time of your function, and it is going to print how much time did it take, and it will return the same result. And if you also pay attention that it is having, I've put the type hints here just to make you understand that the runner function actually takes the same number of inputs and it produces the same number of output. Sorry, same kind of input and same kind and same number of input, and produces the same result, which is integer. And if you see your nth Fibonacci number, it also takes an integer and returns an integer, which is same as the runner function. So that runner function can actually return the result which was produced by our original function. I hope I have made sense till now. Now let's try to execute this. Okay, I have, yeah, let's try to. So I'm computing the third number, I hope. Okay, if you see, this statement is coming from your runner, which means your decorator was successful in replacing your function with the inner function, with the closure, and it actually computed the total time it took. So because I said that I'm having this sleep of 3 seconds, if you compute the third number, it will take around 3 seconds of the time. So it's printing this total execution time of the function Fibonacci. Sorry, total of the function nth Fibonacci is 3, and third number in the Fibonacci sequence is 2. It's coming from here, outside statement. So I hope it was fine to understand till here. It was easy for you to follow till here. But we haven't seen decorators yet, and this is the tutorial about decorators. If you see this line is actually replacing your function, and Python has got a syntactic sugar for it so that you don't have to write these lines. What you can do, you can comment out this one and simply go ahead and write something like this. And this is what your decorator is. By seeing this, Python will immediately understand that, okay, you need to replace your this function that you are decorating, which is your original function, with another function which is going to return by this decorator. The decorator is also another function, which is this one, outer function. And Python will immediately replace your nth Fibonacci number with whatever is returned by your decorator. And so that you don't have to explicitly replace it. And whenever you invoke your nth Fibonacci number, it will call your runner. and runner will have that extra capability of computing the running time. So what other examples can we think of? So one more example that I can think of is if you have written REST endpoints, you're creating a backend and you have written endpoints and for to serve the REST API requests, REST API requests. What general practice is that if and your endpoint is actually for that particular request, your endpoint that you have written, it is going to access really critical resources in your system. You will always want to validate that incoming request. So for that, you can have a common decorator. So all those endpoints that are going to access critical resources in your system, you have to put the validator on the request, so that whoever is requesting is actually a validated individual, is authorized individual to perform the action that your function is going to do. And you can keep a decorator, and that decorator can perform all those input validations and authorizations for you. That's another example. Let me tell you of another simple example. Is if the previous example was hard to follow. For example, you have written a function which will divide numbers. So you pass two numbers, a or a comma b, and the function returns you a divided by b. That's the result. But as we know that division by zero is not defined, is undefined. So you will have to put the input validations here as well. However, you can do it using try and except block, but the intention here is to make you understand about decorators. So what you can do essentially is that you can create a decorator which will replace your function with another function that's going to run the original function but also perform input validations, so that if there is a divided by zero, it can raise exceptions. However, it's not the best way to do it, but I'm actually explaining this so that you try to get that feeling. Okay, where can you use decorators? I hope this was pretty easy to follow, and you now know, okay, what is decorator and why do we need it. However, in the coming videos, it will even get clearer to you that and you will start seeing the actual use of decorators. Okay, there is another example that I would like to tell, and really important thing. This is important to understand when your decorators are executed. When does Python actually replaces your function with the original functions? And there is a common misconception that whenever you call your function, that is that whenever you call your function, then Python actually replaces your decorator, your function with the function that is returned by the decorator. But that's not the case. Let's try to understand this. Let's try to understand this by an example, if it was not understood till now. So here is a sample decorator you can think that I've written. Generate random is the name of that decorator, and it contains an inner function which essentially does nothing. It actually runs that function and returns the result. That's all it does. It actually does nothing extra. But just to demonstrate it, I've just written this sample decorator. So there's inner function and this generate random is the outer function, and this is the decorator body, which means if this body is executed, which means your decorator was called, and it is going to return this inner function from here, which is actually going to go and replace your function, the original function, decorated function. Now, let's see when this is called. So we have a function. This is my original function or the decorated function. We are decorating it with generate random, and I have imported this generate random. Main thing to note here is that I have not invoked my function. This function has not been invoked anywhere in the file. So what should happen? Essentially, it looks like uh, there shouldn't be any action. Python should do nothing because we are not doing anything with this function. And let's try to understand. Let's try to see. Okay, I'll execute it without this decorator. Example 2. If I execute it, nothing happens, nothing gets printed. But let's say if I decorate it, this is what comes here, which means even though you haven't invoked your function, Python recognizes it and actually replaces your function with the new function, or that closure, that inner function, because you have decorated your function. Okay, let me come to the original question. When are decorators executed? So the answer is decorators are executed at the import time. What is import time? When your file is loaded. And when your file is loaded, it is scanned by Python interpreter, and it does that scanning and reports any issue if there is. And at the same time, if there are any functions that are decorated, it is replaced with the new function, so that from now on, if you're going to invoke it, it will actually call the so when you call it, it's actually going to call the inner function, this one. So let me print execute it again, and yes, so this function was executed. This is coming from what was returned from the inner function, and this came from the this point, from your decorator body, which means your decorator has replaced your function with the new function, which is this inner function. Okay, so with that, I would like to close this video. I am trying to make an effort to keep my videos smaller, but also I want to provide a rich content so that you actually get to understand things in depth. So I'm sorry if it was too long, but it's going to teach you a lot. So with that, if you like the video, please hit like, leave a comment, share it, subscribe to my channel, and I'll see you in the next one.